All right, welcome back. We're going to pick up with the second part of the tutorial on latent topics. Let me share my screen here. So here are the instructions for coding task 2. We're working with the Li Auto and Rivian Automotive SEC end of year filings, annual reports. In the first tutorial, we talked about you start with these 3 text documents, Li Auto and Rivian, and then the combined text, and we have these 3 scripts. Actually, there's a 4th one now, which is to help us do our final analysis. It's a concatenate and pivot scores. So if we look at the file now, you should start, your scripts folder should have 4 scripts in it. Last time we used just 1 and 2. Your data folder should now have combined Li Auto and Rivian text documents, but you should also have tokenized documents of the combined folder. We created that last time. And your analysis folder should also have several files. These 4 files here, the LDA model combined, these were created when we exported or saved the latent topic model. I'm saving the one with 3 topics. You'll save the one with 6 topics. We also have the graphs, the coherence score graphs that we created. This is the topic document score matrix that was output by the second script. And this table, the latent topic table, you could make by hand. I asked you to make this one by hand. So this would include your topic IDs, the scores, and the labels, and then also the bag of words. You can sort these, from in order of topic ID or in order of the score, however you like. I just put the top 3. You'll do the top 6. So this is where we finished, where we left off after the last tutorial. What we're doing in this tutorial, so last time we generated the latent topic model. What we're doing this time is a comparative or historical analysis using the latent topic scores. So we'll divide the corpus according to the research design. In this case, we're doing a 2-case comparison. So we're going to divide. We have the corpus is divided into Li Auto document and the Rivian document. But if you were doing a 2-period comparison, you would create a text file containing the text for each period. Or if you're doing a 2x2 design comparing 2 groups over 2 periods, you'd create 4 text files like group 1 period 1, group 2 period 1, group 1 period 2, group 2 period 2. If you're doing time series, you would create a text file for each unit of time. So 2010, 2011, 2012, each year would have a text file containing the relevant text for that year. And then we would get, latent topic scores for each of those slices in time. So, but for this one, we're going to keep it simple. We're just doing the 2-case comparison with Li Auto and Rivian. So here, today we're going to run let me open up Jupyter Notebook. Right? So here in Jupyter Notebook, I have my project file, module 2, latent topic modeling. I'm going to go into the scripts. We've got the 4 scripts. Today we're going to run we're going to calculate the latent topic scores for each group. So we're going to use this third script to calculate the latent topic scores for Liato, and then we're going to use it again to calculate the topic scores for Rivian. There's one point here though, which is that in order to calculate these latent topic scores for Liato and Rivian separately, we need to work off of the processed, tokenized versions of Liato and Rivian, and not the raw text. So if you have in your data folder, sorry, so in the data folder, these tokenized docs combined, they do contain the tokenized, fully processed tokens for Liato and Rivian, but from the combined file. If we had tracked these and marked them as Liato and Rivian, then we could just take these and divide them up, and then like put the Liato tokens and the Rivian tokens, run script 3 on those separately. But we didn't do that. So the easier way to do that today is simply to run script 1 over the Liato data and run script 1 over the Rivian data separately, so that we get tokenized docs for Liato and tokenized docs for Rivian. And then we'll use those tokenized docs for each of those groups. We'll use those to calculate the latent topic scores. So let me just, to highlight this again, right? And I even put it in red here because I think it will be easy to forget. First step will be to run script 1 on each of the above text files, on each of these, on the Liato text file and the Rivian text file, in order to pre-process and tokenize the text for each group. The step is easy to forget, but it's critical. If you try to run script 3 on the raw text file, you're going to get weird results, right? So let's do this one first. If I go to, so first I'm going to open up pre-processed tokenized documents. It's loading slowly because I'm running Zoom at the same time. To show you the data file, we're gonna run script 1 on this Liato file and then on the Rivian file. So, okay. So here, right now, because we just, this is how we ran it last time on the combined text, I'm gonna hashtag that, and let's run it first on Liato. So I'm gonna save this, and then I'm gonna click here, restart the kernel and rerun the whole notebook. And that will run everything from top to bottom. So restart the kernel and rerun the whole notebook. Yes, I will lose any other text that was in here, any other variables, but it will run the script from top to bottom, and I don't have to click like one at a time. So restart and run all cells. So it's going to restart and it'll run through all of these. Okay, you can see it's got stars. So it's running through each of these steps one at a time. And it's going to tokenize and lemmatize. It's gonna process the Liato text file, and when this one's done, when this star changes to a number, we'll know that it's been exported to our data file, to the data folder. Still have stars there. So just a word of caution, this button, you know, running the kernel, running the whole code all the way through is very convenient as long as you know that your code is set to do everything that you want. You know, when we go step by step, we have a chance to double check. Did we, you know, change a parameter, something that we forgot to change back, right? So as long as you're confident that this code is correct, then you don't have to go step by step, and you can just, you know, run this. If you're uncertain, it's good to go through just one time, line by line to the bottom. We're getting held up on something. What are we doing? Okay, I think we did the, oh, it's doing the parts of speech tagging. So let's see. Okay, finish that. Finish that. This is the Liato file, so there were, you know, 5,900 documents, and it's all done. So if we go to the data folder now, you can see it's created this tokenized documents for Liato. Okay, so now we're gonna redo that for, I'm gonna go back up to the top of the file. I'm going to select, I'm gonna hashtag Liato and select Rivian. I'm gonna save this, and I'm gonna do it again. Restart and run. I will pause this and resume when it's done. Okay, you can see it finished tokenizing and processing the Rivian one. And if we check in the data folder, now we've got tokenized docs for Rivian as well. So, so that completes this step here. We've run script 1 on each of the text files for each group. These will be the inputs for script 3. So now that we have these tokenized docs right in script 3. So I'm going to close script 1 here. Let me reset this back to. Save that. Now I'm going to open up. We've already generated the latent topic model on the combined corpus. So now we're going to calculate the latent topic scores for each group. So I'm opening up script 3. And we're going to run script 3 on each of the tokenized docs files, once for Liato, once for Rivian. And then this is going to calculate the latent topic scores for each group. And this script is going to save these scores in an Excel spreadsheet. And then script 4 will take those multiple Excel spreadsheets and concatenate them, combine them into one Excel spreadsheet with all the latent topic scores side by side, so that we can do analysis. So here, script 3. You'll notice we're importing a few extra libraries now. We're importing pandas and matplotlib because we're going to do a little bit of analysis in this script as well. So if you run those and you don't have those, you may have to run, you know, pip install, like I showed you in the last script, to install pandas or whichever library you don't have. Okay. So here's our data path. So now I'm going to open up, see here, same as script 1, but the file name now is the tokenized docs file, not the raw text. So we're going to run the script first on the tokenized documents for Liato, and then we'll run it again for the tokenized documents for Rivian. So just to verify, we've got the tokenized documents for Liato. Open that file. We're going to tokenize those documents. We have 5,468 documents. And this is an example of the first one, right? So you can see it's fully processed. all lowercase, all stop words removed, lemmatized, etc. Okay, the other thing that we're going to import from the analysis folder is the LDA model. So I'm going to import or load the LDA model with 3 topics that we saved last time. And you can see that is here. So we've imported the LDA model and we've imported the tokenized documents for Liato. And now we're going to use the model to calculate the latent topic scores for the documents in Liato. So here's some functions that I'm just saving. Okay, so I need to vectorize my corpus on the Liato tokens, and I've done that. And now, just a reminder from the LDA model, these are the 3 latent topics with all of their loadings. I have 3 latent topics. We have 5,468 documents. I think I forgot to delete this from the last one. We're not going to create a new topic document score matrix, but it would have that many values. We could have a minimum cutoff. I'm actually not using a minimum cutoff in the algorithm, so this is not really necessary, but you could set that if you wanted. Okay, so let's create. Oh no, actually we are going to create a document, topic document score matrix, because that's how we're going to calculate aggregate the latent topic scores for this. So okay, so here's the data frame. The data frame will have a topic ID, our subgroup, which is either Liato or Rivian, the document ID, the score, and whether the score is significant according to our minimum score here. All right, so I'm going to run this over the whole corpus, the Liato documents. And that will take just a minute. I think normally my computer processes this more quickly. I think since I'm running Zoom at the same time, it's telling me I need to get a new laptop. Let's see. Okay, so I finished that, and I can check out that document, topic document score matrix. These are the exact same scores that we calculated last time for the whole corpus, except, right, these are just specific to Liato. So these are the 5,467 documents. And remember, every document, so document 0 here, every document has a score for every topic. One thing I didn't mention last time, what exactly is the score? What exactly does the latent topic score mean? The latent topic model it's a mixed I said mixed model. No, it's a classification algorithm, but we say it uses fuzzy logic or mixed membership classification. So what that's saying is, notice that these 3 numbers for document 0 add up to 1, right? 0.95, 0.959, 0.02, and 0.019. These 3 things together add up to 1. So what that means is these are not probabilities, but these are proportions. So the LDA algorithm thinks that for document ID 0, the proportion of the document, so 95.9% of the document is referring to topic 1, 2% of the document is referring to topic 0, and 0.019, or 1.9% of the document is referring to topic 2. These are not probabilities. So this is not saying that document ID 0 is topic 1 with a probability of 96%. It's a proportion. So it's saying that document ID 0 is both topic 1 and topic 0 and topic 2 all at the same time, but in these respective proportions. So that's a difference between a fuzzy logic classifier, where these would be probabilities of being one class, versus a mixed membership classifier. So I just wanted to kind of explain what those scores are. And so you'll notice for any document, right, here's document 5467, the scores for topic 0, 1, and 2. Again, you can see these 3 scores add up to 1, right? So that's important later because when we decide how to compare latent topic scores across groups, right? The easiest way to compare them is as proportions of the discourse. One consequence of this is that the latent topic model assumes that every document will be addressing at least one of these topics. So, in some cases, like this document 0, for example, this is effectively, it's saying this document is effectively about topic 1, and these are basically 0, pretty close to 0. But in any case, you will never find a document where these 3 proportions don't add to 1, right? So this could be a weakness of the model, if you like, that, maybe not every sentence in the document is really talking about these 3 topics, right? But in a, had we let the latent topic model run 1,000 to 1,000 topics or 10,000 topics, right, then it could have generated enough topics to cover every single document. But because we chose to limit the number of topics to only 3, right, now we're forcing the algorithm to assign a proportion, for every document to every topic. So, okay, I just want to kind of explain what these scores actually mean. So now that we have that, let's aggregate the latent topic scores for Liato. So these are this is the total number of documents. This is the score, the sum of all those scores. We can create an average score. So, right, taking the sum and then dividing it by the document, we get this average score, 0.275, 0.351, 0.373. Notice that these 3 also add up to 1, right? So what are these average scores? These average scores are actually the proportion of each topic across the entire Liato corpus, right? So this is saying essentially topic ID 0 captures about 27.5% of the documents, of the sentence, of the text of Liato is addressing related to topic ID 0, which I think was like business and business operations. And then topic ID 1, which was addressing law and like regulations, capture, that topic is being discussed about 35% of the time. And then this 37% in Liato, right, is talking about what was that third category? It was, like stocks and shareholders and things like that. So that's the third category. And so for Liato, that's the highest proportion, right? The latent topic that has the highest proportion in that text. So we can order these just to, if we order them by average score, right? Then the second topic is captures the largest proportion, topic ID 1, the second most, and then topic 0, the third most. So we're going to run this again in a minute for Rivian, and then we'll compare these average scores, right, or these proportions of each latent topic across the two corpuses and see, you know, are they discussing these at the same proportion or a different proportion? Okay, so let's create a file name. So we'll export these scores as scores 3 topics Liato and do that. We're saving these to the analysis folder. So if you open up the analysis folder now, we should see the new Excel file right here, scores 3 topics Liato. I include this 3 topics here because maybe you'll run this for 3, you know, for the latent topic model with 3 topics, maybe you'll run it again with 6 topics. So I just want to, we have file names that kind of, you know, disambiguate. So those are the scores for Liato. If you open it up, you can see I'm just saving the aggregate scores. So that's all I'm saving is the topic ID, the subgroup, which is Liato, the sum of scores, the document count, and the average scores, which are the proportions of each latent topic across that group. All right, so what else are we going to do? So so this is really the core, you know, this is really the point of the script, but I wanted to also give you some tools here to identify high scoring documents for each topic. So recall, like, part of the assignment is to label these latent topics. And maybe you want to see within Liato or within Rivian, what are the documents which score highest on a particular topic. So for example, let's look at the the topic document score matrix. So these are sorted by topic ID and score. So for example, for topic ID, for the topic ID 0, in the Liato Discord, in the Liato text, document ID 535 has the highest score on 0. Let me narrow this down. So what if we want to find like the top 5 documents for a given latent topic? So for example, for latent topic 0, we want to find the top 5 scoring documents. So let me go through these. Okay. So in that case, for topic 0, the top 5, you know, the highest scoring documents are document 535, 382, 1948, 902, 640. Right? These are scoring like almost 100% on that particular topic. For topic ID 1, if you want to check that one out, just change the topic number or ID. And for topic ID 1, these 5 documents are the highest scoring, right? So I think that's the same code here. Find the top n topics. Yeah, so that's just a duplicate. Okay, so let's say with this now, you want to go look at document 2286, because you want to know in Liato for topic ID 1, which is about law and regulation, you know, what does Liato say about that? So you can go down here and to search for a document, just put in the document ID number 2286 and run that. And this is the, right, you can see the score here, again, 0.997. Like it's the score is almost 0 for this topic and almost 0 for this topic. This is these are some of the keywords, right? I mean, these are the tokens in that document. If you want to see the actual raw text, right, for this, let's see, can we do that easily? I think it would be hard because even if I split the text on periods, like we removed a lot of documents after processing, so the numbers wouldn't line up. What you would have to do is take a strange keyword in here, like procuratorate, right? And then search on word, or search on 2 or 3 of these words in the original document to pull up that sentence and to look at it, right? So I'm not going to do that here because let me see. Let me do it real fast. So if we go to the Liato, SEC form, and let's search on, that's a very strange word. I don't even know how to pronounce it. Procuratorate. Remember, topic 1 is about laws and regulations, so a lot of legalese in here. Loading the inline form. And this is Liato, right? If we search for that word, we find it twice. We find it twice in the same sentence, right? So basically, this is that sentence. Right? So this is the text. This is the document in this whole, text of Liato, which most epitomizes or best represents what latent topic 1 is in the Liato text. Pursuant to the notice of the Supreme People's Court, the Supreme People's Procuratorate, and the Ministry of Public Security on lawfully punishing criminal activities. I mean, this is a long sentence, but basically, this is what we're talking about when we're talking about latent topic 1. So that's what you can. I think I put these tools in here, like find the top and documents for latent topic and pull up, search for that document as a way to kind of, to go back to the text to kind of characterize and contextualize those latent topics to help you label them and to know kind of what they're talking about. Okay, so we've done that for Liato, and now we have to do it for Rivian. If you were doing this for a time series, you would do this, 2010, 2011, 2012, you would run this each time. And every time you run it, it's going to export one of these scores. Right? It's going to export the topic scores for that data point, Liato, Rivian, whatever. So I'm going to rerun it, and I'll just click here to restart the kernel, run the whole thing. Yes. And that will take us to the bottom of the file, and we'll wait until it finishes processing that. Okay, so we ran the script 3 again on Rivian. Remember, we ran it on the tokenized documents, not the raw text. And it got through everything except for this last box where it gave us an index error, list index out of range. The reason for that is because in this last box, we searched for document 2286, but if you go up here, to the summary statistics, the Rivian corpus only has 2131 documents. So we were searching for a document number that's larger than that, that's outside of the corpus. That's why it returned an error. But it doesn't matter. It got through everything else. So here now we have the topic document score matrix for Rivian. Let's go down. We output these scores, 3 topics Rivian. That should be in the analysis folder. So if I update my analysis folder, right now I've got the topic document scores for Liato and for Rivian separately. And I can still use these same tools. So if I want to find the top 5 documents for latent topic 0 in Rivian, I can run this. Right, and it gives me 1447, 322, right? And these are all pretty high scoring in Rivian. So, and then if I want to search for one of these documents, let's say I want to look for document 1447, I can look for that here. And that's here's the document score, right? It's supposed to be high on latent topic 0. Also plan, make corresponding investment facility, commercial operation, technology, future operation. But remember topic 0 was about business and operations. So that seems pretty consistent. Let's look at another one. Let's say we want to see the top 5 documents for latent topic 2, which was about stock and share prices, and then 188, 2050, 81. These are the top highest scoring documents. So let's look at document 188. Requirement vary depending location, regulated activity conducted. Okay. We don't see anything about shares or stock directly, but apparently those are high scoring keywords. Let's look for other ones. Let's try the next document, 250. Yeah, form, indemnification, agreement, director, officer, right? So now we're definitely talking about, you know, responsibility to shareholder kinds of things. Let's look at 81 one more. Let's see. Highly dependent service reputation. It looks like we missed that. We should have gotten rid of symbols like that with the pre-processing, but I guess it's not perfect. Let's try 1956. WA activity year ended December, right? So this is, you know, year-end reporting, all consistent with that, you know, those SEC requirements. So dependent service reputation. Robert, I'm not sure what Robert is. I wonder if that's like a, let's go and look at the Rivian form. I don't know if Robert is a person's name, you know, some regulator or a CEO, or if it's like some kind of a consulting service. Oh yeah, okay. So we are highly dependent on the services and reputation of Robert J. Scringe, our founder and chief executive officer. So I'm guessing, you know, there are 9 references to Robert, the CEO. Okay, so anyways, I think, yeah, the bag of words for latent topic 2 are less, you know, don't stand out as strongly to me as the bag of words for latent topics 0 and 1. But I'm also not finance is also not my major, so what do I know? Right, for latent topic 0, this is business and operations. Yeah, we looked at this earlier. Okay, so you can use a script to explore kind of the documents, the high scoring documents. Meanwhile, the important thing is that we output these topic scores for Li Auto and Rivian. We're going to use these in script 4 to actually do some statistical tests and to create some descriptive plots. So I'm going to save and close script 3. I think we're done with these documents. And I'll open up script 4. So if we go back and look at the task instructions, we've run script 1 to tokenize the, Li Auto and Rivian texts. We've run script 3 to calculate the latent topic scores for each group. These have been recorded in an Excel spreadsheet. Now we're going to run script 4 to concatenate these two, the scores for each group, and we're going to compare the scores by group or period if you're, doing a historical analysis. Specifically, we're going to create data sets in pandas using Python pandas that will help us make a vertical bar chart comparing latent topic frequencies across the two groups, and a horizontal bar chart to, showing the logs odds ratios of latent topics across the two groups. So we're going to make these data sets using this script, and then we're going to export those data sets into Excel, and then we'll make the actual charts in Excel. And that will be the end of the scripts. And then once you've done that, you'll report your findings, right? You'll write a 1,000-word report. You'll compare the scores for at least 2 different latent topics. You'll cite at least 3 sentences in the original documents which scored highly on the topics you're analyzing. You'll have to use script number 3 to do this. You can cite these as examples to justify why you labeled a topic a particular way. And you'll make some broader inferences about the 2 companies. In terms of figures, you will include the table from step 3. That's the summary of the 3 latent latent topics, and you'll include the figures that you create in step 4 to compare the latent topic scores across groups. So you'll have a total of 3 tables or figures in your report. So let's open script 4 and create the data sets to make those 2 tables. All right, so we're importing even some more libraries, SciPy stats and NumPy and math, because we're going to be doing some hypothesis testing, some t-tests. We're not importing anything from data. Everything that we're importing now is from analysis. So I leave the path here, but we're importing from analysis. We're going to import anything from analysis that has this prefix, scores 3 topics. Right? You might change this to scores 6 topics. Topic. Your latent topic model has more than 3 topics. So this is the suffix, and then I'm going to grab all the file names from my analysis folder. Right. So these are all the files that are currently in my analysis folder. And then from these file names, I'm going to grab the ones that have this scores 3 topics in front. So that's that. And then these are actually, the files that we want to open. So I'm gonna open both of these files as data frames, as a Python pandas data frame. So it's opening those right now. And you can see it has them as each data frame as it's listing the two data frames in a list. So here's the first one. This is from Liato, and the second data frame here from Rivian. So we have these two data frames, and now we'll hold on to that for a second. And then I'm also creating a function to test a t-test of proportions. But I mentioned last time, I put all my functions at the top of the file, I define them there, and then I'll use them later on. So, if you're interested in, what exactly this statistical test is, it's a two-sample z-test of proportions, and here's how you calculate the statistic, and here's the website talking about that. So we'll use that in a minute. Okay, so first of all, I want to concatenate these two data matrices. And so there we are. I've combined the two data sets, topic ID 2, 1, and 0 for Liato, 1, 0, 2 for Rivian. The document counts, the sum scores, and the score averages, right, for each of these two together. So what I want to show in an Excel table are, I want to compare, for example, topic ID 2 for Liato has this percentage, right, 37.3%. And Rivian for 2 has 17.7%. So I want to show this side by side in a bar chart. To do that in Excel, I need to pivot this table in this way. So Excel prefers that you have the data series across the top as rows, and then you have your x-axis here running along the vertically. So I use this pivot table just to do just to create the table in Excel, and then we're going to export the data frame to Excel to create a grouped bar plot. So I'm going to call this file name scores 3 topics pivoted and export that to the analysis folder. Okay, so let's look at that first. So I should have a new full file here, scores 3 topics pivoted, which is pivoting these two data files produced in the third script. Let me open this up. So this is the pivoted data. The actual numbers that are going to go into the bar chart are here. These are the score averages. I want to clean this table up just a little bit before we make the bar chart. I'm going to delete this row. And I'm also going to clean up these numbers a little bit. So right now these have, I don't know, 10 digits or so. I'm going to round them off to, say, 3 digits. So I'm just going to drag that down and over. And so now you can see here in these two columns, I've reproduced these, but I've just rounded them to 3 digits. And I'm going to copy the Liato. This is the data I'm going to use in the chart. This was the topic ID. I'm going to copy this, including the group names, because those are going to be the series names in the bar chart. So if you click insert and go over here, to the 2D columns. And there it is. That's the bar chart for, now again, how do we label this? Title, the chart title, these are the, let's say, proportions, more accurate, the latent topic proportions by group. A few things I can do. I can add data labels. And now, because I use the ones which are rounded by 3, these are nice and clean proportions, right? If you prefer to use percentages, then just go back here and multiply it. And now these will be percentages instead of, oops, these will be percentages instead of decimals, but these are percents. In that case, we'd just change it to latent topic percentages. So I'll just leave that as it is. The other thing you want to change here is the labels on the x-axis, because this says 1, 2, 3, right? It's just listing them in order, right? But we know these correspond to topic ID 0, 1, and 2. So you could put in you could replace the label here if we just right click anywhere and select data. You can edit these are the horizontal category axis labels. You can edit those, and you just choose the data, the labels that you want without not including the header here. And that now it's, instead of 1, 2, and 3, it's 0, 1, and 2. And we should probably add a axis title. This axis title is the what if we actually labeled or named the latent topics? So in that case, we can just add another column here, and let's call these labels. So latent topic 0, let's just call that topic number 1, business and operations. Topic number 2 was laws and regulations. Topic number 3 was something about and shares. So in that case, we can select data, edit, and let's choose these 3 instead. Now we've labeled those, and if this latent topic is too much, we can go back and let's remove those axis title for the horizontal axis we don't need. Okay, I think that's a pretty clean, good-looking table illustrating the latent topic proportions by groups. And just by looking at this, we can tell for topic 1, business and operations is represented more in Rivian than in Liato. Topic 2 on laws and regulations is also addressed more in Rivian than Liato. And it's topic 3, stocks and shares. We might want to, we were looking at those documents earlier, the top 5 documents for topic 3. We might want to rename this. I'm not sure that stocks and shares is really the best label for this latent topic. So you might want to go back and relabel that. But in any case, whatever that latent topic is, it's discussed more, a lot more, almost twice as much more in Liato than it is in Rivian. So that's something that you'll definitely want to address in your final report. But again, right, I'm just doing this with 3 topics. You'll be doing it with 6. So you might, you'll have different proportions and different topics to look at. So, okay, I'm going to save this one. You can copy and paste this into your report. One thing just as a tip, if you add an Excel table to, this file, scores 3 topics pivoted, was saved from script 4. If you run script 4 again, it's going to save over that file where you just did all of that work to create a figure. So what I do is I usually rename the file. I just that way, if script 4 runs again, it's not going to delete that file, right? My Excel file will be preserved. So that's just a tip, because I've lost, you spend a lot of time formatting your chart, and then you run the script again and it like writes over it, and you have to do it from scratch. So just a tip. Okay, so that's the first graph that we're going to make, comparing proportions by each latent topic. In the next one, we're going to test for significant differences. I want to show you a graph from the German far right online groups paper that we looked at. This is the graph that I want to produce here. But in addition to showing which topics align with which group, I also want to do a statistical test to see which of these, if the difference in proportions is statistically significant or not, right? So we're going to do a t-test, a 2-sample z-test of proportions to test for whether these differences are significant. And then we're going to create these log odds ratios to make this graph. So, and that will be the final analysis we do for this. So here we're doing the test for significance. Here's the pivot table. I'm going to just add some statistics onto the end of this. So we'll need this. All right, these are just some things I ran earlier to make sure I was writing coding it correctly. You don't need those. Okay, so when we're doing our test for significance, we have to specify an alpha level, a confidence interval. So for a 95% confidence interval, that's a alpha of 0.05. So we can set that here. Just making sure I can grab the group name. So here, group 1 will be Liato, group 2 will be Rivian. If you use this script later for your module 2 team project, you're going to be using different group names. So hopefully, as long as you format the title of your data, as long as you write your initial data file like this, whatever, Liato Rivian or period 1, period 2, or group 1, group 2, whatever, these naming formats should carry through all the scripts. So Liato Rivian, and then we're going to add some fields. We're going to calculate the difference in proportions, the z-statistic, the p-value, and the significance. Okay, so then I'm going to run the t-test on. So basically what I'm doing is for each topic, I'm comparing this proportion to this proportion. I want to know for Rivian, is 0.354 minus 0.275. That's about a difference of what, 0.08 approximately. Is that a significant difference? So we'll run this, and it gives you a more detailed output probably than you need. But the two sample z-test of proportions for latent topic 0. Liato is 0.275, Rivian is 0.35. That's a Liato minus Rivian. That's a difference of minus 0.079. Here's the z-statistic, the p-value, and in this case, Rivian is significantly larger than Liato at a level of 95%. So, right, that p-value is almost 0, right? So, as long as the p-value is less than alpha divided by 2, then it's significant. So for latent topic 1, right, again, 0.3517, 0.468, Liato minus Rivian is minus 0.11. There's the z-stat, there's the p-value. Rivian is significantly larger. And for this last latent topic, Liato is larger than Rivian, right? We saw that in the Excel spreadsheet. That third one is larger for Liato. Here's the z-stat, the p-value is basically 0, so Liato is significantly larger. So for all three of these, the differences are statistically significant, right? When you do this on different data, you might find some overlap and some don't, right? I mean, some latent topic proportions might be equal in the two groups, and then might be larger for one or larger for the other. Here's the pivot table. And here for significance, I just showed like significantly larger for group 2, which is Rivian, and larger for group 2 Rivian, larger for group 1 Liato. Okay, so then I have 3 queries here. So the first query is latent topics having similar frequencies. Are there any latent topics where the significance was, I have to change this, where the significance is where it's not significant. And how did I save these? Oh, I gotta go back up to the not significant, right? Not significant group 1 and group 2. Those are the values we have. So here. So there are no latent topics where where the difference was not significant. So this is outputting a table with 0 entries, right? If it was significant for group 1, we can see topic 2. Liato was latent topics where the proportion was higher for group 1 than for group 2. So only topic 2 was higher for Liato than Rivian. And here, topics where proportion is higher for Rivian than for Liato, topics 0 and 1. Right. So this tool just lets you query, once you've calculated the significance, you can see, are there latent topics that are not significantly different across the 2 groups that are essentially the same proportion, latent topics where group 1 is higher, and latent topics where group 2 is higher. And then that log odds ratio of latent topic proportions table is going to show us the kind of illustrate this in a graph. So I'll calculate the log odds ratios. You can do a search to figure out how I calculate that. It's essentially, I mean, here's the formula here, but essentially you're dividing this proportion by this proportion and taking the log of that. That's a log odds ratio. It's just a way to spread out the proportions from positive numbers to negative numbers. Anything that's positive is going to be more significant for Liato, and anything that's in the negative range is going to be, significant for Rivian, significantly larger for Rivian. I grabbed the data set that we need for Excel. I'm going to save this as scores 3 topics log odds, and we'll save that to Excel. So now we go to Excel and we look for this file in the analysis folder. And there it is. So we had the pivoted one with that we added the figure to. Now we've got the log odd ones. I'm also going to create a figure for this. So I'm going to add a figure. And if we open this up, okay. So we're going to use this data to create a horizontal bar plot that looked like the one in the German far right online group one. So to do that, I'm just going to take this one series of data right here and insert recommended charts. I'm going to insert a horizontal bar chart. Let's see, all charts do we have. Can look for bar chart. Yep, that's what we want. So this is the basis of the graph. And then these are the log odds ratios. Log odd ratios of latent topic per person. Just leave that as it is. Now, here the labels 1, 2, 3. Again, those are corresponding to the data as it's ordered here. So, 3 here is, let's do the same thing that we did last time in round names. And for the data here, so I'm going to take this title. Let's base the graph on these rounded ones. So insert recommended chart, this one. Okay, this is the title. But we need to do a little bit of formatting. So first we need to change the labels. So here, remember topic ID 0 was topic. Topic ID 1, that's our second topic on law and regulation. And the third topic was so now if I go here and change the select data, and we're going to edit the horizontal axis category. It's not horizontal actually, it's vertical here, but because it's a horizontal bar chart, they didn't change that. So okay, so we've got the topic names here, but I don't want these in the middle of the of the chart. So if we click on these, we do want to format these. We should be able to format them. Actually, maybe if I just right click here, can I? So I'm gonna click on format axis, right? So what did I do? Let me go back. So I'm right clicking on these and click on format axis, and then go to text options. No, axis options, and this alignment. And then we want the vertical. Do we want top alignment? No, I don't think that's going to matter. Text direction, that's the same. Okay, so I think we go axis options and click on the chart here, axis options, and go all the way down to labels. And then if you click on labels, you can change the label position from high, none, oops, low. Low is not bad, but I want them to be aligned, and I think they will align better here, high. So I'll put them on the right side, and then they're kind of aligned with this axis. And then let's add axis titles. So these are the log odds ratios. These are the latent topics. But actually, I don't think we need that label. So we'll uncheck the vertical. Okay. The last thing I want to do here is to color them separately. So recall in that in the German one, they colored one group white and one group black like this. So we can do the same thing manually. So if you click here on this, let's say, anything which is above 0, right, which is going to be significant for Li Auto, you just click that one bar. Like if you click the bar first it'll choose all 3 of them at the same time, but if you click it again, it'll just select that single bar, and then we can change the fill color. Let's change it to black, and the outline also to black. And then on this bar, maybe we can choose these 2 at the same time. Maybe not. Okay, so this one, the fill to white and the outline to black, right? And then this one, the same. Fill to white and the outline to black. Right? So we can kind of format those. And I think that's good enough. We've got log odd ratios of latent topic proportions. We need to specify that anything greater than 0 is going to be significant for Li Auto, and anything less than 0 is going to be significant for Rivian, but you could do that in the text of the graph. So this is good. You can include that in your report. And let me close Excel. Just close that. And remember to add, figure to the end of that so that if you run script 4 again, it's not going to write over that figure. So that is everything. So you've finished script 4, you've exported those 2 data sets to Excel, you created a vertical bar chart, you created a horizontal bar chart showing the log odds ratios. You've also identified which of those bars are statistically significant, or which of the latent topics are statistically significant and in the direction of which group. And so kind of include all of that in your report. And again, remember, with these latent topics and these measures and all this analysis, the point is to use these measures and citations and the references from the documents and all these statistics to generate some broader inferences about the 2 companies. So clearly, Liato, there's more discussion about these shares and stocks, what we're calling topic ID 3. Maybe we need to relabel that. But in any case, why is Liato talking more about that one? And whereas Rivian is spending more time talking about business and operations and law and regulations. So try to come up with some insights about that based on your analysis. And I'm going to upload this to the code to Moodle along with the instructions, and I'll also upload this video. So, and let me know if you have any questions.